Hello. So today we'll be starting Bode plots for gate. Basically, when you are understanding the Bode plot, what it means is that you are varying two quantities. One is your magnitude, another one is your phase. But you will be varying it with the logarithmic values of frequencies because the range of frequencies that you need is from point 1 to infinity. The problem here is that because log 1, if you take log 1 is equal to 0 or log 0 is equal to infinity, right? You can't start, Bode plot never starts with log 0. It starts with a value of 0.001 or zero point 0.1. You can just use the calculator and you can just check. If you put 20 log 0, let's say, it will give you a math error. So because that tends to infinity. But you 20 log zero point 0.1, you get a value, right? Minus 20 dB. So in Bode plot, what happens exactly? The magnitude, okay, of any transfer function is expressed with logarithmic values of frequency, and the phase of that function is expressed with the logarithmic values of the frequency. And now to understand the Bode plot, will be utilizing a semi-log paper. So in the semi-log paper, we have y-axis on a linear scale, but x-axis is on the log scale. So these are the logarithmic values. It starts, see, the graph is starting from point 1 because log 0 is infinity. From point 1 to 1, it shifts, right? So this is called one decade. Again, from 1, it will shift to 10, then 10 to 100, then 100 to 1000, so on and so forth. Okay. So some elementary rules of log. Why we utilize Bode plot? Because in Bode plot, multiplication and division gets replaced by addition and subtraction. Because you already know log a plus b is log a plus log a to the power n and log a, and log a by b will be given as log a minus log b. But here one important formula is you need to understand. For example, you have frequency here. Let's say this frequency omega 1 here is zero point 0.2, okay? And you have another frequency, let's say omega 2 is zero point 0.8. So this frequency value, if you have to calculate the decades that have passed between them, okay, number of decades is given as log to the base 10. This is the normal log function in the calculator. The ln function is basically log to the base exponential. Log e is your ln. Normal log function in the calculator. So number of decades would be equal to log of, okay, the final value, that is omega 2 by omega 1. This is a very important concept. Gate utilizes this. I'll show you in the later functions. Now, when we are moving to the Bode plot, for example, any standard form of the open loop transfer function, let's say this is my g of s, this is the open loop transfer function. This I have put as k dash is equal to s plus z1, s plus z2, s plus p1, s plus p2. So these are the numerator is the zeros and the denominator are the poles. Okay. Let's say this h of s is a unity function for now. So whenever you are utilizing the Bode plot, so you have to put your s function as j omega. Once you put the s function as j omega, so it converts to j omega here, right? I'll use a different color because I already written it to reduce time. So this is basically okay. So j omega and my function becomes this. Now notice here in this particular thing, I told you addition and subtraction in the logarithmic value. Now any value if I multiply by 20 log to the base 10, okay, any magnitude, it converts to dB. Okay, this is dB. 20 log to the base is a dB. Okay, and octave 6 dB per octave is also equal to 6 dB per octave is also equal to 20 dB. This thing you have to keep in mind. Okay. You see here, this is a one function, this is another function, another. So I keep this A, right? I write here A, this as B, this as C, and this as D. So my function became 20 log K A plus A B C D. This function now 20 log I multiplied. Now I am having GJ omega in dB, right? In dB I am having. Now I can break out this function. See, log multiplication is there. This can be written, the top product can be written as it gets right. Log A, B, C can be C. Log A, B, C, right? And 20 is also multiplied. So this is basically 20 log A plus log B plus log C, right? plus log C. And the division fraction becomes minus, right? Log C minus log D. Yeah. So if you right see, just you see the division has reduced into subtraction and the multiplication has reduced into addition. So that's the reason why are we utilizing the Bode. Now I've already shown you out there. Okay. So this is basically the standard form of the transfer function. Note here, any one of the two can exist here. Either the zeros can exist, either the poles. Both cannot exist simultaneously. Why it is happening? So suppose my S value is, for example, 2 here and P value is 1. So this would be S square by S, right? So this gets cancelled in S. Suppose both are same, S by S gets cancelled. So at a time only, suppose this is my another value, right? Suppose this is S cubed. So this gets cancelled. So only one will act as a trie. 1 by S behaves as an integrator, okay? Poles, and S behaves as a differentiator. This thing you have to keep in mind. Very good. Now, see, now if I have to reduce this Bode plot into a time domain form, so what I do is the same function I take, and this Z is tends to 1 by T. So S by Z, I take this Z out, so 1 plus S by Z, since 1 by Z is equal to T, I can replace this function Z is equal to 1 plus TS. So I am just replacing here. On the same concept I'm doing here also. Okay, it's written over there SP and the things are there. Okay, because I've divided this by Z. Okay, I have divided this by Z. When I divide this by Z, so it becomes S by Z1, right? So that is 1 by Z1 is T. So it 1 by, see, 1 by Z1 is T, right? T1. Same way. So I can replace this function. If I do this math, I get this in this particular form. This is called the time constant form of the Bode plot. Now, very important thing that you need to understand here, the reverse plot, like they will give you the plot and they will ask you to draw the transfer function. That is very important here. Now notice, this is my the time constant form I have written. Okay. Now notice, if the value of k is greater than 1, so the magnitude is shifted above, right? Suppose this is your 0 dB axis. Okay. And if your k is greater than 1, magnitude is if the k is less than 1, okay, the magnitude of this Bode plot will be, see, the negative slope is represented like this. So this is minus 20 dB slope, and the positive slope is represented like this. Suppose this is 0 dB, and here there is a 20 dB line. Okay, 20 dB. This would be represented like this. Suppose this is your minus 20 dB over here. So this is, see, this contribution of minus 20 dB is due to poles, and this contribution of plus 20 dB is due to zeros. This thing you have to keep in mind. Okay. Now another important fact over here is that, suppose, now what about the magnitude of this? See, the phase angle is calculated. Let's say I'll take one small example over here and I'll show you the phase angle. Okay, just a second. Yeah, here is my book. Let me show you. Okay, one of the examples. Okay, for the phase value. Okay, one for three. Okay. Mm, quadratic factors. Okay. Yeah. Okay. Let it be here. Okay. So I have this. I have an. I'm already written over there. Let's say my this Gj omega and Hj omega is equal to, let's say, 2 j omega 1 plus j omega by 2 and 1 plus j omega by 20. Okay, let's say this much. So 1 by j reflects your angle at the rate of 1 at an angle of minus 90 degree. And this angle you will get tan inverse of imaginary part by real. J tan inverse of omega 2 by 1. Omega by 2. Here also it would be into tan inverse of imaginary, real part is 1. omega by 20. So the total contribution, there is no imaginary part. So this 2 means at an angle 0. Suppose it was minus 2 written over there. Then minus 2 would have meant basically 2 at an angle 0. How you got? You got 2 cos 0 plus j plus 2j sine 0, right? Cos 0 is 1. But if you want minus 2, so 2 at an angle 180 you have to write. So 2 at an angle 180 would be cos 180. Cos 180 is minus 1. So in that scenario, you to take cos 180, right? Cos 180 plus j sine 180. Sine 80, sine n pi is 0, right? Sine n pi is 0 always. So this will become minus 2. So this thing you have to keep into mind. Now, as far as the pole is concerned, so pole is the integrator part. It contributes how much? The magnitude of it would be 1 by omega, right? Suppose you are having one pole at origin. Okay, so what would be the magnitude in dB? So its contribution is so basically its contribution is 1 by omega. So in dB, we'll write 20 log 1 by omega. Okay, so 1 by omega can be written as 20 log omega inverse, right? And you know this n log a can be written as, see, if you have x, if you have log a to the power x, it can be written as x log a, right? So here also the same thing I have written. So x value is my equal to minus 1. This is my x value, okay, minus 1. And a value is of course log omega. So I have written this. So you have seen what is happening. This is contributing basically. If I take this down here, so it will give me basically minus 20 log omega, right? Minus 20 log omega. And if I put the value of omega as zero point 0.1, starting value as zero point 0.1, right? So minus 20 log zero point 0.1, if you just calculate, it's my calculator. Yeah. So minus 20 log zero point 0.1. So you'll get how much? You will get 20 dBs. So this would be, see, log log 10 is equal to 1. Okay, because 10 to the base you are doing, right? 10 to the base, log 1. So this will contribute you 20 dBs. Okay, so that means a pole is always contributing minus 20 dB. Okay, now let's move to the zeros. Okay, so this is the same thing I have explained, 1 by s by p omega p. So this is if you have p number of poles, so the contribution would be minus 20 into p. Okay, and if you have zeros, right, zeros are the numerator part. In that scenario, your contribution would be how much? Your contribution would be equal to, see, 90 into p, because zeros are s, right? So you have straight away 20 log, replace that value by omega. Okay, omega power p. So this can be written as 20 into p log omega. Okay, so put this 10 to the base 10, this will become 1. So in short, it is p into 20. P into 20. Okay, and same way, as far as the poles are concerned, it will, as angle is concerned, it like say 1 by j omega is there, right, for the pole. So it will contribute, see, the more number of j's if you do, right, 1 by j, or if you do 1 by j omega to the power p, it will contribute minus 90 into p. Okay, angle contribution. 0 will contribute plus 90 into, okay, the number of zeros whatever there are available. Now the procedure to draw is basically, Bode plot is express the given g of sh in the time quarter, draw a line of 20 log k. Okay, k is the initial slope, right? So basically, how do you calculate this initial slope? You calculate this initial slope by this intercept, y is equal to mx plus c, and c is what? See, mx is what? See, mx will get by 20 log k, but you also have to take the this contribution due to the lower frequency region, contribution due to low frequency region. So this low frequency region, how do we get? I'll be showing you. Okay, so primarily you have to first decide these things. Okay, and everything I have written and I have explained very beautifully. So now see, suppose, see, let's say कि suppose we have omega is equal to 1.5. Okay, any frequency, this 1 plus c, I had put in this form now, 1 plus s t1 of s. Wherever, see, this t1 of s, this is called a corner frequency. So this frequency omega 1 would be equal to 1 by t1. Okay, same 1 plus s t2 of s. So this omega 2 would be equal to 1 by t. Okay, suppose we have a corner frequency at omega is equal to 1.5 and there is a 0. So what this 0 does, it adds a plus 20 dB. Let's say at omega 3 we have a pole, it adds minus 20 dB. Okay, and at omega 10 we have a 0, it adds again plus 20 dB. Now the important factor here to keep in mind is that now from omega 1.5 to omega 3, slope will be due to omega 1.5. So slope would be 20 dB. But as you are moving ahead of omega is greater than 3, so that means 3 to 10, the slope would be the previous slope plus the slope contribution by 3 dB. So the slope from omega 3 to 10 would be 0 dB. Why? Because the previous slope was plus 20 dB and the new slope is minus 20 dB. So slope is previous slope here and contribution due to the pole, so 0 dB. Now in the same way, if you are moving 3 to 10, it remains the same. But if you are moving ahead of 10, contribution there is 20 dB. So and the previous contribution is 0. So the slope after 10 till infinity would be 0 plus 20. It would be 20 dB. Okay. So this is the main concept that you have to understand. Now let's analyze this problem. One of the problem is given. Okay, an asymptotic plot has been given and it is starting here from 80, I think, yeah, let me just check. Yeah, 80 dB. So it is starting there from 80 dB. So its initial slope, if you look at this question, so what it is saying is that it is initial slope is given. Okay, and you have to identify the transfer function of this. So now there are two things. Hmm? How do I identify? So initial slope from point 1, okay, up to the value of, see, there are, see, corner frequencies are omega is equal to 2, right? Omega is equal to 5 and omega is equal to 25. Okay, right. Now we have to identify which are the zeros, which are the poles. Now initially it is starting itself from minus 40 dB. So minus 40 dB start initially, is it possible due to zeros? No, it is possible only due to poles. So that means it is having two poles at origin. Two poles at origin, right? Because the contribution of the poles is how much? I told you the contribution of the poles is minus 20 dB into 2. Then only you will get minus 40 dB, correct? So two poles at origin means 1 by s square. Suppose if I had three poles at origin, it would have meant 1 by s cube. So one term is clear. So s square term is there. S square term here. So these two A and C are wrong from the initial. Okay, we conclude this. Now initial slope is there. Now, what is happening to the slope at the value 2? Right, at the value 2, the slope is changing to minus 60 dB. Right, at the value 2, the slope is changing to minus 60 dB. So that means from point 1 to 2, what was the slope? The slope was minus 40 dB, right? And 2 to 5, the slope it is showing is minus 60 dB. So that means here there is an addition of 1 minus 20 dB, right? So again minus 20 dB, then only it will become minus 60 dB. So again, if you are adding minus 40 dB, minus 20 dB, that means this contribution is due to the pole. So that means pole is at 2. So that means this 1 by, this thing is also correct, right? 1 by s plus 2 is also a pole. Okay, then we are moving from 5 to 25. So when we are moving from 5 to 25, 5 to 25, it is going to minus 40 dB, right? Minus 40 dB. So it is going, so the previous was minus 60 dB. So it is only possible if I had plus 20 dB here, right? Then only minus 60 plus 20 will move to minus 40. So plus 20 dB addition is due to the 0. So that means at S is equal to 5. Okay. At this point, at omega is equal to 5, we are having S plus 5. Okay. Which is nothing but a 0. So then we are having S plus 5, S plus 2. Okay. We saw here also we are having S plus 2 and here also S plus 20. Okay. So these now B and C are very much similar. Now if I'm moving ahead of 25 dB, now the contribution is again minus 60 dB, right? Minus 60 dB. Now this contribution minus 60 dB, previous contribution was how much? This minus 40, right? Again it has to be a pole. Again we are adding a minus 20 dB. So it has to be a pole. S plus 25 is a pole there, right? S plus 25 is a pole there. And S, this is a 0. So these are matching. But now we have to calculate the value of K. Okay, now how do we calculate the value of the K? See here, this is 80 dB given, right? This is the initial. Okay, how to calculate this? This is very important. So magnitude will be equal to the gain effect. Okay, so the gain effect is C. Here one formula I'll be using. So we need to calculate K. K is given by C. Magnitude is equal to the gain effect plus slope effect. Initial slope effect is basically contributed by the zeros or poles at dot. It is contributed by zeros or poles at origin. Poles at origin. Now here you notice gain effect is basically 20 log K. Okay. Magnitude is 80 dB. This is coming from this equation. Y is equal to mx plus c. This is the equation. Okay. This is the slope effect. This is the slope, right? And this is the gain effect plus the initial slope. So how many zeros are there at origin? We saw 1 by s square, right? So s you have to replace by s, you replace here by omega square. S is j omega na. So in this case you just replace it by 20 log of, just you have to take the magnitude, right? So this magnitude, if you have to take magnitude here, so this would be equal to omega square plus 0, right? The magnitude of this, that would be omega. But in this case we are having s square, so it would be omega square ka square root plus 0 ka square. So that would be your omega square. So this would be 1 by omega square, right? Again this is in dBs, 80 dB. This is your 20 log k. This is the log k value you have to calculate. This is 20. Okay. Log omega to the power minus 2, right? So you just bring down, you use that formula, right? A log a to the power x n, right? This you forgot. Log a to the power, this can be written as n log a, right? Same formula. So this can be written as plus 20 minus 2 into log omega is equal to 20 log k. 20 log k. So this is your 80 dB. So here if you just calculate this value, okay, now what are the values that you'll be getting? Just calculate the value for this k. So this is your 20 into minus, so log omega value here, 20 log omega, poles at the origin, so this is 20, so this is minus 40. Okay, so this will give me a result. Just a second. 80 20 log. Okay, then if you just put the value there, this calculator I will show you. 6 point, yeah. So here, yes. So if you put the value there, right? Omega, see, initial slope in the graph only, you see initial slope is at 0.1, right? Initial slope. So now you just put this as 80 dB is equal to 20 log k, and this would be minus 40, right? This minus 40 into log of 0.1. Just put the calculator, log of, just a second, log of 0.1 will give you minus 1, right? Log log zero point 0.1, the result is equal to minus 1. This would be equal to 80 dB is equal to 20 log k. This is minus, and this is 40 into minus 1. So this is plus 40 dB. So this is 80 minus 40. This is 20 log k. So this value becomes 40 divided by 20, right? Log k. So this is 2. Take log inverse. Log inverse, how do you take? K is equal to log inverse of 2 means if you just want to eliminate this, you just have to put k is equal to 10 power 2. Okay. Suppose it was let's say k, you had, okay, log uh, 20 log 100, right? K. Then this would be 20 cancel 5 here. So k would have been 10 power 5. This is the same thing. So the answer came as 100, correct? The answer came as 100 there. So this k value became 100. So you have the answer over there. It was a very tricky question. They had asked for 2 marks, right? The options are very close. Yeah, 100. 100. I have written the 8.17. Yeah, 20.17. Yeah, k is equal to 100. K value will come as 100. Correct, na? 100. Okay. 20 log k is equal to 40. K value is 100. And then you have, okay, 100 s plus, okay, this is not correct. This is also not correct. This is also not correct. Another trick, another trick what they have applied is, okay, s square s plus 2 plus 25 s plus 5, okay, and k. Okay, they have written this in time constant form. Okay, I'll show you. The time constant form basically means this is the same thing. So what I do is why the value 1000 came, because they have written it in time constant form. In the time constant form, I'll just show you. See, g of s, the can be written as, c, k into, I told you now, 1 plus s by 5, right? The time constant in the normal form they are writing, okay. Then s square 1 plus s by 2, okay. Then 1 plus s by 25. Now, if I have to write this in the time constant form, right? So what I need to do here is, hmm, so 1 by 5, I will take out s by 5. I can take out from here. I can take the values there. I can multiply this by 5, right? Okay, this equation by 5 and divide it by 5 also. If I do this, k into 5, if I write k into 5, what is the value that I'm going to get inside? So one value will become equal to, see, this s value will be 5. If I take out s value is 1 by 5 over there, right? I just multiply it with 5 there, 5. So it is becoming 5 plus s, right? 5 plus s, and then divided by also 5. So I'll show you one sec. What I have to do over here is, yeah. So this g of s value is equal to 100 into 1 plus s by 5. Okay. So this answer actually I got equal to, see, 100 s by 5, then s square 1 plus s by 2 and 1 plus s by 25, right? This I can do now, this thing. Like in the previous scenario, if you just you check back to my the article number 1 where I have explained the very beginning of it, and then I can take this 2 and 25, I can multiply, and there I can multiply by 5, right? So this is 100 into 5, and this will become my s plus 5 over here. Just a second. This will become my s. Yeah, this will become my s plus 5 over here, and then down there s square. I take the 2 value out, 2. So this will become my 1 plus s plus 2, correct? S plus 2, and here also I take the 25 out, then it will become s plus 25, s plus 25, right? So I got this as, yeah, correct now. So this I got as 500, and this 2 and this 50. So this value is s square s plus 2 s plus 25. Very good. When I'm doing this, I need to do both ways. Now I need to divide and multiply. So I'll divide here by 5 and here by 50, right? So this becomes my 5 cancels over here, and but I don't get the answer there. Why the option they have given like that? Okay, let me just go back. Okay, value is coming as 100. Okay, just a sec. No issue. So this g of s value is equal to 100. Hmm, and my transfer function, okay, g of s I can express like this: k, okay, 1 plus s by 5 divided by s square 1 plus s by 2, correct, and 1 plus s by 25. This is your k dash, uh, whereas your k value is equal to this. That function only that in the beginning I have explained you in the first page, right? In the beginning, first page, I have explained you this concept. Yeah, this is based upon that concept only. So you need to practice a lot. See that first page when I started the frequency domain analysis. So when we started about the transfer function form, so this is of this particular nature. So what, see, normal transfer function is this: as s sz value, uh, k dash into sz by s plus z1, right? S plus z1, and this is s plus z2, right? Divided by sp, s plus p1 and s plus p1 and s plus p2, the same form. So here the k value is basically z1 into z2 into p1 into p2 into this k dash. So the value k dash you have got 100, right? And z1 value is equal to 1 by that 5. So z1 is your 5. Okay, z2 is not there. Sorry, z1 is 5, and this is 2 into 2. This would be 1 by 5. 1 by 5, no, this would be 2 into 2 into 25 into 100. I'm not getting this. Yeah, 5 he has taken this. Something this is very typical Bode plot question. Anyways, we'll start with this again. Okay, in the next class, I'll just go through it. It's not that easy to make it on live.